Hello and welcome to my science tutorials. In today's video we are going to be looking at basic trigonometric identities and then how to use these basic identities to prove trigonometric equations. So without further ado, let's get started. So the first of the trigonometric identities that we want to look at is the equation given to us by cos squared theta plus what? Sine squared theta is equal to 1. Sine squared theta is equal to 1. So this is the first trigonometric identity we want to look at. So equation number 1. Now from this same equation number 1, you can make either cos squared theta the subject or sine squared theta the subject, and you can get another derivative from this identity. So we can get cos squared theta, in case we make that the subject, to be 1 minus what? Sine squared theta. Okay, or the reverse is also possible. We can have what? Sine squared theta to be equal to what? 1 minus cos squared theta. So these three identities are very useful when we want to prove trigonometric identities. Now the second identity that we want to look at is 1 plus what? Tan squared theta. Tan squared theta is equal to what? Sec squared theta. Okay, so this identity is also very important. We normally use them when we want to we use them in equations to prove certain cases. So assuming, for instance, you are to prove that something is equal to something in trigonometry, and then you happen to come across tan squared theta and don't know what to do again. Okay, you can just quote this identity and make tan squared theta the subject, which will give you what? Sec squared theta minus 1 when you bring the 1 to the other side, so that you substitute sec squared theta minus 1 over there as tan squared theta, and then from there you can move on forward and solve your problem. Now the third and then the final identity that we'll be looking at before we move on to solve any question is what? 1 plus cot squared theta is equal to what? Cosec squared theta. Okay, so this is the third identity that I want to look at. So the third identity is giving us what? 1 plus cot squared theta is equal to what? Cosec squared theta. Now these identities, like I said earlier on, you can just make change of subject. You can make cot squared theta the subject over here, and then you get an expression for what? Cosec squared theta with 1, that is making cos squared theta the subject. So you can manipulate this to get another equation, which can also be useful or relevant when you are solving trigonometric equations, or you have to prove certain cases in trigonometric equation. Now at this point, I'm assuming you already have an idea of the basic trigonometric identities that we have. What I mean by this is sine square, what is sine theta, what is tan theta, what is cot theta, and the rest. But then just for revision's sake, let's go through very few of them. So when we have cosec theta, okay, so this identity in trigonometry is equal to what? 1 over sine theta. So if you have cosec theta, you can substitute 1 over what? Sine theta for cosec theta. Now if you have sec theta, okay, this is equal to what? 1 over cos theta. This is another identity that or another substitution that can be very useful when we are solving questions. Or we can have cot theta. Cot theta is equal to what? 1 over tan theta. Okay, now the tan theta we are having over here, tan theta, sorry for that background noise, tan theta is equal to what? Sin theta over what? Cos theta. So tan theta is what? Sin theta over cos theta. So if we substitute the whole of this back into this, it means this equation will be reversed for us to get cot theta. So cot theta will be equal to what? Cos theta divided by what? Sin theta for cot theta. Okay, so these identities are also very useful when we want to solve trigonometric equations, or we want to prove cases in trigonometry. So with this basic introduction to the trigonometric identities, let's go ahead to solve an example to actually appreciate what we are doing so far. So the first one we have over here is we have to prove that the case 1 over what 1 minus cos theta plus 1 over what 1 plus cos theta is equal to what 2 cosec square theta. Okay, so let's go ahead. So let's write proof. Okay, so this is how we are going to prove that 1 over 1 minus cos theta plus 1 over 1 plus cos theta is equal to what 2 cosec square theta. So the proof, just like the way we go ahead and solve any other fraction, we first of all find the LCM for this. So for this part of the equation, the LCM will be the product of the two denominators that we have over here. So we have 1 minus cos theta, then we have 1 plus what cos theta. Okay, so this will cancel this, leaving this. So 1 plus cos theta times 1 will give us what 1 plus cos theta. Okay, so this will also come here, canceling this, we have this. So this multiplied by 1 will give us what plus 1 minus what cos theta. Okay, so if we further break this down, we can see that the positive cos theta over here will cancel the negative cos theta over here. So we have 2 at the top, which is 1 plus 1. So we have 2 divided by, if we expand the denominator over here, 1 times 1 will give us 1. Then 1 times cos theta will give us what plus cos theta. Then negative cos theta times 1 will give us what negative cos theta. The negative cos theta times what cos theta will give us what negative cos square theta. Okay, so from here we can see that the cos theta the positive cos theta and then negative cos theta over here will cancel out. So we have 2 over what 1 minus what cos square theta. But then remember, we saw one of the identities where we have what cos square theta plus sin square theta is equal to 1, and then we said we can make sin square theta the subject, which will give us what 1 minus cos square theta. So in this place it means 1 minus cos square theta we have over here is equal to what sin square theta. Okay, so if we all know where this identity is coming from, we can then substitute that in place of 1 minus cos square theta. Okay, sorry about that background noise. So we have 2 over what sin square theta. Okay, so 2 over sin square theta can also be written as what 2 times what 1 over what sin square theta. Okay, but remember I earlier on said I show you an identity where I said let me use another color, where I said what cosec theta, cosec is equal to what 1 over sine, right? Okay, so if cosec theta is equal to 1 over sine, it means what this is it makes sense if we say what cosec square theta is equal to what 1 over what sine square theta, right? So this should make sense. So if this makes sense, it means what we have over here can be written as what 2, then the 1 over sine square theta will be equal to what cosec square theta. Okay, so this is what we were asked to find, and then that is what we have over there. So this is the first example of how we use the basic trigonometric identities to solve problems in trigonometry. So let's have a look at another scenario where we will get to prove something else. So example number 2, we have to prove that cot theta plus sin theta divided by 1 plus cos theta is equal to what cosec theta. So we'll go on ahead and then prove this case. So first of all, what we need to do is we need to simplify the cot theta we have over here. So the cot theta, okay, can be written as what cos theta divided by what sin theta. Okay, then plus what we have over here, which is sin theta over 1 plus what cos theta. So if this holds true, then we then just find the LCM from here. which will be what, sine theta, okay, then 1 plus what, cos theta. Then sine theta will come here, we'll cancel this, we are left with this. So we have this multiplying this, so we have cos theta into bracket 1 plus cos theta, okay. Then we have this coming here to cancel this, then sine theta times sine theta we get plus sine squared theta, okay. So from there we can just expand the bracket that we have to simplify things. So if we expand this, we are going to get cos theta plus what, cos squared theta, then plus sine squared theta all over what, the denominator, which is sine theta, then 1 plus what, cos theta, okay. So from here we can see that we have cos squared theta sine squared theta, which is equal to 1 from the identity, the first identity that we saw, that what, sine squared theta is equal plus cos squared theta is equal to 1. So in place of everything over here, we are going to put 1 over there. So it means from here moving forward, we have what, cos theta plus 1 divided by what, sine theta into bracket 1 plus what, cos theta. Now we can see that we have 1 plus cos theta, 1 plus cos theta at the top over here, okay. So this will cancel this. So in the end we are having 1 over what, sine theta, and then 1 over sine theta is what, cosec theta, okay. So this is how finally we've been able to prove that what, cot theta plus sine theta divided by what, 1 over cos theta is equal to what, cosec theta. So I will want us to have a look at one more example. Let's prove one more case and then we end the tutorial. Now the last one we want to prove in this case is cot A minus 1 divided by cot A plus 1 is equal to what, 1 minus tan A all over what, 1 plus tan A. So this is what we have to prove. We have to prove that this side is equal to this side. So let's get started. So the first thing we want to do is what, to write the cot A minus 1 in its simplest form as much as possible, so that we know we are going to get tan A in the process. So we know cot is what, 1 over tan. So the cot A we have over here is equal to what, 1 over tan A for the cot over here, then minus 1 divided by what, another 1 over tan A for this side, then plus 1, okay. All right, so from here we can let's solve the top one and then the bottom one separately. So let me just make this like this. So the top one, this will be divided by 1, this also divided by 1. So we have tan A as the LCM, then the bigger bracket, which is this, then this one also tan A. So we have this will go here, 1 times 1 is 1, minus 1 will come here, 1 tan A, tan A times 1 will give us what's tan A. Okay, so we are done with the top one. So let's come to the bottom one. We have tan A will go into tan A, 1 times 1 will give us 1, then plus 1 will go into tan A times 1 will give us what's tan A. Okay, so from here onwards we can rewrite everything. So we have 1 minus tan A divided by what's tan A as the top one. Then if we want to bring the denominator to the top, because it's division sign, we need to reciprocate what we have over here so that we can bring multiplication sign over here. Okay, so because we are bringing multiplication sign over here, we need to interchange this. So we will now have the tan A at the top, then divided by 1 plus what, tan A at the bottom. Okay, so we here can cancel this, and then at the end we are getting what, we are getting this fraction. So we are getting this divided by this, which is what, 1 minus tan A divided by what, 1 plus tan A, which is what we are asked to find in this case. So this is how we use the basic trigonometric identities that we have to prove trigonometric equations. So in case you are given any example similar to something like this, you just take your time and see which of the identities you can get after breaking down the question that you have. Just look through very well, or if for some reason you can recall as you are going, you just write the basic trigonometric identities that we have. You just write them somewhere, so that in case you are solving and you got stuck on the way, you just look at the identity and see which one you can make the subject and substitute and see whether you can get the answer. So with practice, you are going to get better at this. So thank you so much for watching, and then I'll see you in the next video. Peace.